Chapter 8 is about central limit theorem. Central limit theorem is used in a situation where we are answering questions about sample means being greater than or less than or between certain values. So for example, suppose we are interested in studying heights of ULM girls. So normally we ask questions like what is the probability that the height of a girl will be greater than 65 inches, or it will be between 63 and 68 inches, things like that. But if instead of asking question about the height of one girl, we start asking questions like what's the probability that in a sample of 20 girls, the average of the sample is greater than 63 inches. So instead of asking about one girl, we're asking question about a sample of 20 girls, or it could be a sample of any size. So that kind of situation calls for central limit theorem. Now, one basic thing about central limit theorem is that if the original population is normal, um, then the sampling distribution of means is normal. But also, even if the original population is not normal, but the sample size is greater than 30, then also the sampling distribution is normal of means. So in other words, for the sampling distribution of means to be normal, either the original population has to be normal or the sample size has to be greater than 30. Now we could have both the conditions as well, but one of them is enough. One of the conditions is enough to ensure that the sampling distribution of means is normal, approximately. And then the mean of the sampling distribution, which is denoted by mu x bar, that's just the same as the original mean of the population. But the standard deviation of the sampling distribution of means equals the original standard deviation of the data divided by square root of the sample size. So n is a common symbol we will be using for the sample size. Okay, now this condition of n bigger than 30, sometimes the software is implying that n is bigger than 30, and sometimes it says greater than or equal to 30. But you will never encounter a situation when the sample size is exactly 30 and you have to decide that, okay, do we meet the criteria or not? Either the sample size will be well above 30 or it be well below 30. It will never be 30 in this course. So with this in mind, let's look at the first problem of the section. And the problem says, let's see. Let's suppose a simple random sample of size n is drawn from a large population with mean nu and standard deviation sigma. The sampling distribution of x bar has mean nu x bar. So we just said nu x bar is just nu, and the sigma x bar is sigma over square root n. True or false, the distribution of the sample mean x bar will be normally distributed if the sample is obtained from a population that's normal regardless of the sample size. So that's true. If the original population is normal, then the sampling distribution is guaranteed to be normal. In this case, we don't require the sample size to be greater than 30. So true. True or false? As the size of the sample increases, the mean of the distribution of sample mean increases. That's false because we have seen that the mean of the sampling distribution is just the same as the original mean. So the mean of the sampling distribution does not depend on the sample size. The standard deviation does. The mean stays the same no matter what the sample size is, but the sample deviation decreases. The standard deviation decreases if the sample size increases because it's in the denominator. So mean stays the same regardless of the sample size. Size increases, the mean does not change. True or false, sampling distribution is normal only if the population is normal. No, that's false because yes, it's normal if the sampling, if the original population is normal, but even if the original population is not normal, but the sample size is bigger than 30, the sampling distribution will still be normal. So let's see, it's false. Sampling distribution is normal if either sample size is bigger than 30 or the population is normal, yeah. So we need one of these two conditions. It's not just this condition. Okay.